Test review for pre-algebra, the first half-ish of chapter 11. We begin here looking at these 8 angles. Now they told us in the instructions at angle 4, I'm going to use blue, I think to make it stand out easier, angle 4, 112 degrees. So we know what that angle is equal to. Now they ask us to figure out then angle 6. So let's start by considering the relationship between angle 4 and angle 6. Angle 4 and angle 6 are alternate interior angles because they're on alternate sides of the transversal, this line, and they're interior, they're between the two parallel lines, they're inside the two parallel lines. And alternate interior angles are congruent, so if 4 is 112 degrees, so is angle 6. Next, they ask for angle 2. Now you could figure this out one of two ways. Angle 4 and angle 2 are vertical. That tells you that they're congruent, so angle 2 is also 112 degrees. But another way you could figure out is 2 and 6 are corresponding. 2 is in the upper right of this group, 6 is in the upper right of this group, so they're corresponding, and corresponding angles are congruent. Okay, angle 8 we could figure out several different ways also. Angle 8 is vertical with angle 6, meaning they're congruent. You could also point out that 4 and 8, since they're both in the lower left of their group of 4, they're corresponding, so they're congruent. 2 and 8 are alternate exterior. They're on alternate sides of the transversal, and they're both outside the parallel lines, so they're congruent. Okay, last is angle 1. So angle 1, best I can see, the only relationship we have when we look at angle 1 is either between angle 1 and 2 or 1 and 4. Angle 1 and angle 2 are a linear pair, supplementary, meaning they form a straight line, so that means they add up to 180. The same is true for angle 1 and angle 4. They also form a straight line, so they're supplementary and add up to 180. So you can say 180 minus 112 to get that answer, and so it's 68 degrees. (14) says a door can swing open 180 degrees. The door is open at an angle of 99 degrees. So this is where you would go in the door right here. This part's a solid wall. This is just where you walk in the door right there. What is the measure of the angle between the door and the door jamb? So we know this one's 99 degrees, and they're wanting to know what is this angle right here. I'm not drawing that to say they're congruent. I'm just trying to show you the angle we're looking for. This is the door. You're seeing it kind of from the top down or from above. These two angles, this one and this one, form a straight line, which means they're supplementary and they add up to 180. So we can do 180 minus 99, and we get 81 degrees. So that angle between the door and the door jamb is 81 degrees. Okay, 15, we're looking at two congruent triangles. And they tell us FGH is congruent to, okay, so we look at F. F is the point that has a 1-tick side and a 3-tick side. So that's the same as L. L is between a 1 and a 3. So we do triangle L, because F and L go together. They're corresponding. G is the one between 1 and 2. M is also between the 1 and the 2. So you go next. And then H, the last letter, is between the 2 and the 3. N is also between the 2 and the 3. Now you may think, well, that's easy. It just went left, top, right. So I just go left, top, right. That is true on this one. You could have done that. But there are times they rotate this triangle, like they could have reflected it and reversed it so that the 2 ticks were over here and the 1 tick was over here. So that's why I was emphasizing you should look at, okay, this one is between these 2 marks. Because that way, if they've rotated this or made it look different than it does here, you'll still know how to do it. 16. On a softball diamond, the triangle formed by home plate, first base, second base is congruent to the triangle formed by home plate, third base, and second base. If it is 65 feet from home plate to first base, how far is it from third base to home plate? Okay, so we know that these are congruent triangles. This is a square, and so if we could just take that and say, well, then it must be 65 feet over there too. Another way you can think about it is this thing is obviously congruent to itself. So that would make these two congruent to these two congruent to these two. So since this one is 65 feet, this one is also 65 feet. So for number 16, it is 65 feet. Now let's switch gears to number 21 through 28. They're wanting us to solve for x, make sure you read the directions, solve for x, then find the missing angle measures. So I do need to figure out what x is equal to, but then I need to plug x in here to figure out what these angles equal. With a quadrilateral, we know they all add up to 360. You can put these in any order you want, but you need to add all these up and set them equal to 360. X plus x is 2x. 2 plus 90 is 92. 92 plus 72 is 184. No. Sorry, 92 plus 72 is 164. My fault. Bad mental math on that one. So we subtract 164 from both sides. That will give us 196. Then we divide both sides by 2. We get x equals 98. So x is equal to 98. That's the first part of our answer. Now the next part is we need to say what these two angles are equal to. Since this one is equal to x, it's 98 degrees. This one is 98 plus 2, which means it's 100 degrees. So you find the value of x, then you plug it in to get the two missing angles. So I started the work a little bit here. I had to correct it, so I went back a little bit. But this is the same step, same process. We'll add these four together that you see here. They have to add up to 360. So then 77 plus 159 is 236. 3x plus 1x is 4x. Then we subtract 236 from both sides. 360 minus 236 is 124. Last, we will divide both sides by 4, and that gives us the value of x, and it is 31. So x is equal to 31. That's the first part of what they ask, but they also ask us to find the angles. So if x is 31, then this one is obviously 31 degrees. This one is 3 times that, which makes it 93 degrees. So I just get 31, and then 3 times 31. 23, they say classify the quadrilaterals shown in the window at the right. Now the book has a better picture of it than me, but these are all kind of diamond shapes. They're not squares. They're more angled like this, but all the sides are congruent. So that means this is made of a lot of rhombi. So we'd say that's a rhombus. 24, determine if it's a polygon. If it is, name it. If it's not, explain why. 24 is a polygon. It follows all the rules. All the lines end where they meet. They don't go past that point. They don't stop before that point. None of the lines are crossing over each other. So this is a polygon. And we have 1, 2, 3, 4 sides. And specifically, this would be a trapezoid because you can tell these two lines are parallel. These two are not. So when you have exactly two parallel lines, it's a trapezoid. 25. Oh, we're also saying whether it's regular or not. Okay. Yes, it's a polygon. It's not regular because regular means all the sides and all the angles are congruent. Well, they don't have any angles or any sides marked as a congruent here. So unless they're marked, you know they're not. So this is not regular because not all the sides are congruent and not all the angles are congruent. 25 is a polygon. It follows all the rules. All the lines connect at their intersections. They don't cross each other. They do meet each other. So it is a trapezoid. Sorry, wrong word. Yes, it is a polygon. And it would be called 1, 2, 3, 4, 5. It would be called a pentagon because it has 5 sides. And yes, it's regular because, as you can see it marked, all 5 of the sides are congruent and all 5 of the angles are congruent. So this is a regular pentagon. 26. Find the measure of an interior angle, so just one. So the formula to get the total number of degrees is n minus 2 times 180. So they ask us how much one angle is equal to, but to get there we'll need to figure out how many degrees there are in total in a hexagon. So a hexagon has 6 sides, so I say 6 minus 2 times 180. 6 minus 2 is 4. 4 times 180 is 720. So that's the total number of degrees inside a hexagon. But they're saying if every angle is the same, if it's a regular hexagon, then how big would each angle be? To do that, you just take the total and divide by the number of angles you have. It gives you 120 degrees. So in total, there are 720 degrees. Divided evenly among 6 angles would make each of them 120 degrees. Now we're going to follow the same pattern here on number 27. We need to figure out, this is a regular 18gon, but we need to figure out the total number of degrees before we figure out how big each angle would be. So 18 minus 2 times 180, because it's n minus 2, and n's the number of sides. So we get 16 times 180, and let's see, 16 times 180 is 2880. So the total number of degrees in this entire 18gon is 2880, but we need to divide that by 18. And we find out that each individual angle is 160 degrees. So a regular 18gon is 18 angles that are each 160 degrees. And our last one, what is the measure of each interior angle of the stop sign? So 28 is very similar to the 2 we just did. They're just not telling us the shape. We've got to figure it out. So hopefully you know this, but a stop sign is an octagon. There's 1, 2, 3, 4, 5, 6, 7, 8 sides. So we'll follow the same pattern and say that the total number is found by doing 8 minus 2 times 180. 8 minus 2 is 6. So we have to do what's in parentheses first. 6 times 180 is 1080. So the total number of degrees, if we added up all these angles in the octagon, it'd be 1080. But since there are 8 congruent angles, we can divide this by 8, and that tells us that each of those angles individually is 135 degrees. So when they ask you to find the measure of an, meaning one, interior angle, you use this formula to find the total, then divide that total by the number of angles in that shape. And the number of angles is the same as the number of sides.